Hello everyone. In today's discussion, I will give you a brief introduction on set theory. Set theory is one of the most basic and primitive concepts in mathematics, and it's created by a paper from George Cantor, who was one of the greatest mathematicians around 1870s. Even though most part of the set theory can be easily understood, it's related to much more complicated topics such as topology and real analysis, and one cannot understand those concepts without being familiar with the naive set theory. Also, most definitions in economics has to include sets on which they are valid to be more rigorous. Hence, the notions you learn here will be helpful to you in the courses you will take. During my talk, I will cover first the definitions related to sets. I want you to pay attention to the sentences I will use, as seeing and understanding a mathematical sentence will be important in some of your classes, such as game theory and statistics. Then I will give you a brief introduction on operations on sets, such as unions, intersections, and complements. And I will finish today's lecture with a proof to show you how to write a rigorous proof in the set theory. So, what is a set? Does anyone have any idea what a set is? So, a set is a collection of objects. It's a very primitive definition which allows anything consisting of objects to be a set. For example, the list of presidents of the United States is a set, or the collection of prime numbers form a set, or a collection consisting of, say, 1, 2, 3, a heart and a circle can be a set. So, if we also have elements of sets. If X is an element of S, then we denote it by this. And we also have a unique set with no elements, which is the empty set, which is denoted by this. We can have subsets of sets. A is a subset of B if and only if all elements of A are also elements of B. And we say that two sets are equal if both of them are subsets of each other. And we have operations. The first operation is A union B. So A union B is denotes the elements that are in A, either in A or in B or in both. And A intersection B denotes the elements that are both in A and B. A complement denotes the elements that are not elements of A. And A minus B is including the elements that are in A but not in B. For example, let's say A is the presidents, A is the list of currently popular singers, and B is the list of US presidents. Then Justin Bieber is an element of A minus B. And finally, we have products on sets, which is one of the most important properties. The elements are the ordered pairs. By ordered pair, I mean the sets with two elements in which order matters. And the elements of A times B are ordered pairs on which the first element is an element of the first set and the second element is the element of the second set. So now we will do a proof with the tools we learned today. Proposition. Proposition doesn't mean anything less true than theorems. It's just another word that mathematicians occasionally use. So proposition our proposition says that for any sets A, B, and C, we have minus interchanges, intersection with unions, and unions with intersections. So, how will we prove it? Those two are sets, and to prove that sets are equal, we learned that we have to show that both are subsets of each other. So we will first show that this is a subset of this, and then this is a subset of that. So to show that a set is a subset of another set, we will take an element, an arbitrary element from this set, and we will show that this is that element is also an element of this set. So let X be an element of this set, then this means X is in A, but X is not in B intersection C. Then this means X is in A, and X is not in B, or X is not in C. Then we have X is in A and X is not in B, or X is in A and X is not in C. But this implies X is in either A minus B or in A minus C, which means X is in A minus B union A minus C. So we show that this set is a subset of that set. And the rest is I'm leaving you as an exercise because it's the same. So today we'll learn some basic definitions on set theory and also how to write a proof in set theory. I hope you enjoyed the class, as it would be helpful in understanding some concepts in economics, especially if you're interested in economic theory. Questions?